All right, so this is the key to functions worksheet 1. So number 1, you had this quadratic function. So let me go ahead and just go ahead and write this. So here's number 1. It was f of x equal 3x squared minus 5x plus 2. And then you wanted to find, in part A, you want to find f of negative 5. Now notice it says show work, so you have to make sure you show the work for both those problems. And then in part B, where you're given this set of ordered pairs, a finite set of ordered pairs, instead of a expression, no work was needed. All right, but in part A and B, you had to show the work. So what I expected you to show is this. So you have f of negative 5, and that's going to equal, so where we see the variable x, you can substitute negative 5. So it'll be 3 times negative 5 squared minus 5 times negative 5 plus 2. And so now we're going to simplify this. So we're going to have negative, remember, order of operations, so you have to do exponents before you multiply. So negative 5 times itself is 25. And then, let me just go ahead and write it. So that's 3 times 25, right? And then negative 5 times negative 5 is a positive 25, and then plus 2. So this right here becomes 75. So we get 75 plus 25 plus 2. And then 75 plus 25 is 100, and then 100 plus 2 is 102. And so your answer, you would say f of negative 5 equals 102. So what we found was that if you were to graph this, which you will at some point, if you were to graph this, when your x value is negative 5, your y value is 2. So that's what you found. All right, so f of negative 5 is 102. Okay, now in part B, though, you want to find f of x plus 4. So you want to transform this expression into a function in which, instead of evaluating f of x, you want to evaluate f of x plus 4. All right, so let me just go ahead and rewrite the function over. So this was my function. And, all right, so in this case, where we see the variable x, you're going to substitute x plus 4 this time. So first thing you had to do in terms of your work, first thing you had to do was go back and substitute in each of these, in each of the variable x's, substitute that expression x plus 4. So you would have had to say 3 times x plus 4 squared minus 5 times x plus 4 plus 2. So you had to show that. Then you had to simplify this. So this part here is easy. Since this is exponent 1 right here, you're just going to use a distributive property. But here, you can't distribute first because this is not a 1 here. That's a 2. So remember, order of operations. You have to do exponents before you multiply. See, this is a 1 here. X plus 4 is 1, and then you multiply by negative 5. So that's why we can easily use a distributive property here. So here, though, you have to multiply x plus 4 squared first. So let's go ahead and do that. So if you did that, you would have had this. X plus 4 squared means x plus 4 times itself. And so when we multiply this out, and most students would use the FOIL method. So you would say x times x is x squared. The outer, x times 4 is 4x. Now remember, whenever you square a binomial, the outer and the inner are going to be identical. So if this is 4x, then the inner has to also be 4x. And then 4 times 4 is 16. Combining like terms, we're going to get x squared plus 8x plus 16. So this quadratic expression is going to go here. So this becomes 3 times x squared plus 8x plus 16. And then let's go ahead and distribute this. So negative 5 times x is a negative 5x. Negative 5 times 4 is a negative 20, and then plus 2. So notice the work he had to show. Then we're going to get rid of these parentheses by using a distributive property now, because this is being raised to the first power. So now using distributive property, I get 3 times x squared is a 3x squared. 3 times 8x is 24x. 3 times 16 is 48. And then let's just rewrite this over. And now combining like terms, I'm going to get 3x squared. 24x and a negative 5x is going to be a positive 19x. 48 and a negative 20 is a positive 28, plus 2 is 30. All right, and so this is, we're done, so this is f of x plus 4. All right, so that's what you would put in, let me go ahead and box this off. So f of x plus 4 is going to be this function. So it'll be 3x squared plus 19x plus 30. All right, so that's going to be f of x plus 4. Okay? All right, so in number 2, you are given a relation here. It's still a function. So notice that this is a function. It's written in function notation. But instead of written in this form, where you have a infinite set of ordered pairs, here you have a finite set. 1, 2, 3, 4, 5. Still a function, because notice for each x coordinate, there's exactly one y coordinate. When x is negative 7, y is 2. There's no other x coordinate with negative 7. When x is 2, y is 6. There's no other x coordinate where x is 2, and so on. So this is a function. It passes the definition of a function. All right, now let's go ahead and rewrite this one. So I'm going to go ahead and do this here. So this is 2. So my function g is this finite set of ordered pairs. So it's negative 7, 2, 2, 6, 0, negative 4, 5, negative 8, and then 6, 3. All right, and then in part A, you want to find f of 0. No work is needed in these. So f of 0, remember, this means what is the y value when x is 0? Well, the only point here where the x coordinate is 0 is this one. And my y value is negative 4. So the answer is negative 4. Okay, part B. You want to find 2 times f of negative 7. All right, so first of all, we got to find f of negative 7. Then whatever that is, we're going to multiply by 4. Oops, all this should be g, I guess. So I'm going to go ahead and, sorry about that. Let me just put that as your function g, because you're dealing with f here. So let me go ahead and make that f here. All right. Okay, so f of negative 7. So f of negative 7, remember what that means is what is the y value when x is negative 7, right? So when x is negative 7, my y value is 2. So this is 2 right here. So now I'm going to say 4 times 2, which is 8. So your answer is going to be 8. So this one is negative 4, and this one is 8. All right, now C. So for part C, you wanted to find f of 6 plus f of 5. So f of 6, remember f of 6 means what is the y value when x is 6? So if I go over here, this is the point where my x coordinate is 6. My y value is 3. So I'm going to put 3 here. Plus, and then the same thing here. What is the y value when x is 5? Well, when x is 5, my y value is negative 8. And then 3 plus a negative 8 is a negative 5. So that's your answer. So that's going to go in this blank, negative 5. Part D, you want to find f of 2, subtract f of 6. Well, f of 2, remember, that means what is the y value when x is 2? So when x is 2, my y value is 6. Subtract f of 6. Okay, so f of 6 means what is the y value when x is 6? So when x is 6, my y value is 3. And then 6 subtract 3 is 3. So 3 is going to go here. And then in the final one, in E, you have f of 2 plus 3 times f of 5. So let's find f of 2 first. F of 2, what's the y value when x is 2? Well, my y value is 6, so 6 goes here, plus 3 times f of 5. What is the y value when x is 5? So when x is 5, my y value is negative 8. So simplifying this, we do multiplication before we add. 3 times a negative 8 is a negative 24. And then 6 plus a negative 24, use your calculator if you have to, 6 plus a negative 24 is a negative 18. So negative 18 is going to go here. Okay? All right, just remember I had to change this because this was function g and none of these dealt with function g. So I just changed the notation to function f instead. All right, so that is it. So that is the key to functions worksheet 1.